All right, so welcome. Uh, Second day of polar is what we're going to do today. And so here's the crazy thing about polar is that we're going to be able to go back and forth between polar coordinates and rectangular coordinates is what I'm going to call the normal XY coordinate plane. And so we're going to go back and forth between them. And then on Wednesday, we're going to go back and forth between polar equations and normal equations or rectangular equations. So that's going to kind of be the trajectory of where we're going for the first part of the week. And then as we finish the week, I'm going to also talk about actually graphing polar graphs. And so hopefully you're studying, hopefully you're practicing, because I know that a lot of this is new, and so it'll really benefit you. So I'm going to kind of go slow and just cover a few things today, and then I'll cover a few more things later this week. Okay. But let's get started. If you have a calculator, grab one, and if not, open up Desmos or something like that, and we'll use that to kind of get us started. Okay, so here we go. We're going to do a little bit of review. Hopefully that works out well for you. But I'm just going to ask some questions here. Can I appropriately plot a point in the polar coordinate plane? And hopefully the answer is yes. We all make mistakes, but hopefully the answer is an emphatic yes. So let's practice. Do I know which quadrant -9, -5 pi thirds would be in? So -5 pi thirds would be in the first quadrant, but then I would have to go and reflect it over the pole, and so our point would be in the third quadrant. So I'm going to say quadrant 3, okay? And then once again, I'm going to ask this question, true or false? 20 minutes of homework a day keeps the F away. The answer is an emphatic true. This stuff is new, so as you work with new stuff and you've never seen polar before, it'll really help you cement in some good practices. If you practice for at least 20 minutes a day, I think that would really benefit you. All right, so here you go, pop quiz. If you want to press pause on the video, you can plot both points and see how it goes. All right, otherwise you can keep watching and you'll see kind of how it goes. So 3 pi fourths is the angle I got to find, and then -3, so I got to reflect it over the pole. So I'm going to zoom in a little bit. So here's 3 pi fourths, but then I got to go over the pole. So 1, 2, 3, plot it right there. Okay, so that is the first point. I'm going to switch colors. Second point, -pi fourths, so that means I'm coming down in the clockwise direction, and 3 going out, so same point. Oof. Tough pop quiz. They're at the same point. Both number 1 and number 2 are right there. Okay, so hopefully you got a 100% on that quiz. 100%. I'm 2 out of 2. Booyah. Hopefully you also are 2 out of 2. Okay, quiz coming later this week. All right, quiz coming later this week. All right, but anyway, hopefully you can plot those points. We talked about this in the last lesson, that multiple points, right? Multiple points can end up at the same spot. If they end up at the same spot, that's fine. It's not like if you were in rectangular, if I say plot the point 5, 6, you're like, oh, okay. You're like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, right? And there's the point 5, 6. The only point that's going to go right there is 5, 6 when it's in rectangular, right? When it's x, y. But the idea behind polar is that since you're going around circular, right, and you're going around the pole, because you're rotating around the pole, which is the origin, right? Since you're rotating around the pole, you could have points landing in the same spot over and over and over again, as well as because the radius is negative. But in rectangular, it's like, boom, this is my only point. It's going to end at 5, 6. It's 5, 6. So anyway, you can have multiple points that all end in the same spot. So we did this on the last lesson. I figured we might as well try it again, just to kind of make sure everybody is feeling good about this. So if you want to press pause you're more than welcome to press pause. Otherwise, I'm going to find two unique polar coordinates that will plot the same point. Okay, here I go. So I'm going to plot the same point first. So 5, then 11 pi 12. So 11 pi 12 is over here in quadrant 2, and I'm going to go out 5. 1, 2, 3, 4, 5. Okay, so a couple things I could do. One that I like to do is just do the negative angle. So a negative angle means I'm coming this way. I'm getting it there. So what would that be? That seems like 13 pi 12ths, but negative. So I could do 5 and then negative 13 pi 12ths. And then another one we could do is we could do, maybe we could do a positive angle. Let's keep an angle positive. Like to be positive on this Monday. We'll go positive angle, but then we go with a negative ratio, right? So if you were over here and then the negative, or not negative ratio, negative radius, the negative radius would cause you to reflect across the pole. So I'm going to go negative 5 comma 23 pi 12ths. Now there's obviously lots of other ones you could pick, but those are the two that I'm going to go with. They are two unique polar coordinates that would graph the same point. Okay. All right. Hopefully that's making sense. If not, send me emails, talk to me through Canvas or through anything else, Remind, and just ask me questions about plotting points. But we're going to move on. All right. So here's going to be the toughest part for many of us, and I'm going to write it right here. Is the toughest part for many of us is that we are not going to read the instructions. But if you read the instructions, then you will know exactly what to do. So we are trying to go from polar to rectangular. So what is that saying? You're given r comma theta, and you're trying to move this into an x comma y point, right? So no longer are we going to have a radius and an angle, but we want to just have a normal x comma y that would actually plot the same point, okay? And so there's a way that we go about it. So from our understanding of how radii and angles and everything have been connected to x and y throughout your trig life, we've always said that x is related to cosine of theta and y in the unit circle is related to sine of theta, right? But we won't necessarily be dealing with a unit circle. Remember, a unit circle means that the radius is 1. But if the radius changes, right, like as we see here, the radius is 12, over here the radius is 10. So if you have a circle with a radius of 12 or 10, how could you get the x value? Well, it's just a scalar. So by that I mean you just are going to multiply by it. So we're going to take this understanding, and if you can say, we're going to translate this to multiplying by the radius. So x is going to equal r cosine of theta. So r times the cosine of theta, and y is going to equal r times the sine of theta. Okay, and that's it. So if you can imagine, this is the radius already, as we talked about before. It's just there's a 1 in front of it because the unit circle has a radius of 1. But now that we're not guaranteed to have the unit circle, we're going to kind of go with r cosine of theta and r sine of theta. This should be pretty straightforward because you've been given, if you're in polar, which we're in polar, you've been given a radius and you've been given an angle. And so really you just got to set it up. So we're trying to go into x comma y, right? That's what we're trying to do. This is r and this is theta. So x we said is r cosine of theta, and y is r sine of theta. And that's it. And so then this point will just be 12 times cosine of 7 pi over 6 and 12 times sine of 7 pi over 6. I would encourage you not to use a calculator for this one, just because you should know cosine of 7 pi over 6 and sine of 7 pi over 6. So 12 times negative rad 3 over 2. and then 12 times -1/2. And then that would be -6 rad 3 and -6. And think about it. These are in the same spot. Like what I usually do to check my answer is I say, okay, what quadrant would this have been in? Okay, so if I draw it, okay, boom, boom, 7π/6 is here, and the radius is 12, so it's going to go out 12, so it would have been somewhere in quadrant 3. Well, remember, this is xy, right? This is now in rectangular. So how would you graph -6 rad 3, -6? What would you have done? You would have gone, oh, okay, I got to count over, then I got to count down. So boom, there it is, right? It would have been in quadrant 3 as well. And so they line up. They should still be in the same spot, right? Just because you're converting this now, right, is in rectangular, doesn't mean it should be graphing a different point. It should be graphing the same point. It's just in a different form, okay? But you will need a calculator for this one, right? If this is the radius and this is the angle, right, it looks like it's xy because it's 10/3, right? But we're saying the radius is 10 and this is 3 radians. So 3 radians, this would be like quadrant 2, right? Just before you get to pi, 3.14, that would be like 3 radians, and then you would go out 10. So this is in quadrant 2 of a polar plane, and so now we have to convert it. So it would be r cosine of theta, r sine of theta, okay? And we should be doing pretty good, okay? So r cosine of theta, r sine of theta, and we'll see how this goes. R is 10, so 10 cosine of 3 and 10 cosine or sine of 3. Okay, so hopefully that works out pretty well. I need a calculator. Make sure you're in radians on Desmos. I'm gonna just use my phone, if that's all right, and I'll just kind of talk it through. 10 times cosine of 3. Make sure you're in radians. Radians. So I got negative, and let's just go, it's like 0.89999. So negative 9.9 is what I'm going to go with. And then the next one is 10 sine of 3. I got 1.41. Okay, which if you think about it, if this is x and y, which it is, that means you would move, right, over to the left, and then you would go up to plot a point, which is also in quadrant 2. All right, so that's how you convert from polar to rectangular. But the key here is going to be read instructions, because you want to know, I mean, because think the real issue, the reason I'm harping on this is because 10/3 is really the main culprit. This looks like a normal XY point, but it's not a normal XY point. It's polar, and we need to pay attention to that, okay? So read the instructions, see what they're wanting you to do when you're converting, okay? And make sure you have a calculator. All right, now we're going from, rectangular, so XY to polar, r comma theta. So we're saying, all right, first and foremost, we need 2 things. Right, 2 things in order to write it in polar. You need, first thing, the radius. I wonder how we could come up with that. And then 2, we need the angle. All right, so here's what we're going to do. Let's just pretend there's a point in the first quadrant, and this is the point XY. Yeah, everybody following? Because I just don't want to give you the stuff and then be like, all right, memorize it. That doesn't make much sense. I think we're all smart enough to figure out where X and Y can help us find R and theta. All right, so if I put a point in the coordinate plane, and it doesn't matter which quadrant I put it in, but I put it here, I can always draw, right? I can always draw a triangle.
We've talked about this in the past. Now, the beauty of this is if I take that point and I were to rotate it around 0, 0, it would make, this is not a great circle, but it would make a circle. And the circle would be a radius r. So if you start to look at that, okay, how could I come about finding this diagonal, right? Let's highlight it. How could I find this diagonal? Hopefully everybody in their minds or in their homes or on their phones or wherever you are, you're saying, I know how to find it. I can do it. This is the X and that's the Y. Excuse me. And we have made a right triangle, and this old dead guy named Pythagoras had said x squared plus y squared equals r squared. So if we're trying to figure out the radius so that we can go into polar, how wonderful. This -5 is the x, this -12 is the y. If I want to find the radius, I can just do the Pythagorean theorem. It should help me find the radius, no problem. Second, how could I find the angle? Okay, well, what's the angle, right? Let's kind of really get in here a little closer. This would be the angle that that point creates, right? Here's theta. So let's excuse r for a second. Let's not worry about r. Let's just go back to the idea that, let's say we only really know x and y, okay? If all I really know is x and y, what is the angle that this point creates? Well, the angle that this point creates, what trig function could I use? Well, if I know the adjacent and I know the opposite, it makes sense that I would use tangent of theta, and that would equal y over x. So if I want to find theta, I could do the inverse tangent of y over x. And that would get me the angle. Now here's the thing, please remember that inverse tangent only gives you an angle from -pi/2 to pi/2 when you're using your calculator. So that presents a challenge. It only spits out an angle that's in quadrant 1 or quadrant 4. So if for some reason the point ends up in quadrant 2 or 3, you're gonna have to do a little bit of work. So we're gonna mess with that here. But this is all you're gonna have to do to find the angle, and this is all you're gonna have to do to find the radius, okay? So here we go. All right, so let's plot one. We have the point -3, 5, and we're trying to go from rectangular to polar, r comma theta. So this is the goal. This is where we begin. Okay, so just to make sure everybody's clear, this is in quadrant 2, right? If this is x and this is y, over 3 to the left and up 5, that's quadrant 2. We want to make sure that our polar point is also in quadrant 2. All right, so here we go. To find the radius, right, because it's r comma theta, the radius is going to be found by doing -3 squared plus 5 squared equals r squared. So 9 plus 25 equals r squared, 34, r squared square root, r equals rad 34. Okay, theta, the angle, okay, is going to be done by doing, theta is going to always equal the inverse tangent of 5 over -3, y over x. Now, here's the other benefit of using the inverse tangent. Let me just remind you, is that the inverse tangent, right, can take any ratio, right, on the inside. So we're not going to break any rules. This is the benefit of using the inverse tangent. We'll always be able to find an angle. So that's a good thing. So you need a calculator. You can be in degrees or radians. I would just read the instructions. I'm in radians. So I'm going to do inverse tangent of -5/3, and I get -1.03. Okay, so that's in quadrant 4. And so think about this. This is in quadrant 4, and we're saying that the radius is positive. So if you're in quadrant 4 and the radius is positive, it's going to stay in quadrant 4. But what quadrant is your point supposed to be in? It's in quadrant 2. So there's a couple ways that you can go about this. So I'm going to let you hit pause and maybe talk it out with yourself about the ways that you can make it end up in quadrant 2, or you're going to just hear me end up in quadrant 2. The first way to do it would just be to take that radius and make it negative, right? So here could be a possible answer. Right, so a possible answer could be negative rad 34, comma negative 1.03. What does that mean? That means this angle is in quadrant 4, but because the angle or the radius is negative, it reflects over the pole and ends up in quadrant 2. Another thing you could do is if this is in quadrant 4, this angle is in quadrant 4, you could make the angle go into quadrant 2. So think about it this way, right? Here's negative 1.03. You could make it go into quadrant 2, right? Which would be from here to there with the same reference angle. This is 1.03. So to figure out this angle here would be pi minus 1.03. And so if I do that in my calculator real quick, pi minus 1.03, I get 2.11. Then I could keep the radius positive, square root of 34, and then the angle is 2.11. I'm just going to encourage you, right, because that makes it in quadrant 2 angle with a positive radius, so it stays in quadrant 2. I'm just going to encourage you, really read the instructions. Sometimes I'll say that the radius has to be positive, so therefore then you would have had to go with this answer, okay? Sometimes I'll just let you do whatever you want, and then you could go with either answer, it doesn't matter. Or you can come up with another one that works. The key is that it's got to end in the same quadrant as the original point that you started with, okay? All right, so if you want to hit pause and try one on your own, I would do that now. And if you can do this and you can do the above problems, then you're feeling pretty good. These are the tougher problems. The ones above should be pretty straightforward. But if you want to hit pause, now's the time to do it. Otherwise, I'm going to get going. All right, so this is in quadrant 3. Remember, this is XY, and we're trying to go into polar. And so I need a radius, right, which is going to be found by doing negative 5 squared plus negative 12 squared equals r squared. And if you know your Pythagorean triples, you know that the radius is 13. And then I need an angle. And the way we're going to find the angle is that theta is going to be the inverse tangent of, well, two negatives make positive, so 12 over 5. Let me use my calculator. And I get 1.176 radians. 1.176 radians. Okay, so here's the point that I have. I have 13, comma 1.176. This is not the right answer. If you got this, this is wrong. And the reason it's wrong is because this is in quadrant 1. You need it in quadrant 3. So if I were to graph 1.176, let me just point it out. 1.176 is in quadrant 1. That's this angle. You need to be in quadrant 3. And so the way to do that would be to add pi to get all the way over there, so that it has a reference angle of 1.176, but it's in quadrant 3. So we need to add pi to this, and then it'll stay in quadrant 3. We don't have to do anything to the radius. I suppose we could. Oh, silly me. I suppose I could have just made the radius negative, and then it would have ended in quadrant 3. That's a thing. But I guess we could have possible answers. 1.176 plus pi is 4.318. So I've got one answer. So 13, comma 4.318. That's the answer that I was talking about. But then as it hit me, I really could have just done negative 13, comma, 1.176. So if it doesn't say, I guess I could go with either one. But if it had said a positive radius, then that one. Or if it had said a negative radius, I'd go with the second one. Hopefully that all makes sense. If it doesn't, feel free to email me, write a comment in the video, or whatever else ways you can get in contact with me. But just trying to keep it simple. So today is just going back and forth between points, polar and rectangular. And then on Wednesday, we're going to go back and forth between equations. So we're expanding. So we started with how do you plot a point? Now we're talking about how do you convert points? And then we're going to talk about how do you convert equations. And then from there, we're going to graph. Okay? So hopefully it's all making sense and you're enjoying polar. It really does get pretty exciting. And I hope you guys have a great day. Okay? So have a good one.